Hey kids, Flexing Teacher Weber here. And the first video I did today, we had just done an introduction to square roots. So square roots are the side length of a square. And when we have a perfect square, we get an exact square root. And you sort of just recall those by memory or with technology. But what happens if you don't have a perfect square? So let's take a look at this. So we started this activity in the previous video, but now we're going to focus on estimating square roots that aren't perfect squares. So what we did today is I gave the kids some grid paper, and we looked at, for example, how would I figure out the square root of 12? How would I estimate it? Well, we could use a calculator, and I showed them how to do that, but we're going to focus on mental math skills, how to do this, and represent it with a picture, how to understand what a square root of an imperfect square looks like. So what we do here, if I want to estimate the square root of 12, what I do is I think of the perfect square that is below 12. Well, the perfect square that is below 12 is a square that has an area of 9. So I'm going to draw that on my grid paper. I'm going to draw, that's not an area of 9, but this will have an area of 9. It's a 3 by 3. So that square has an area of 9. But I want to draw a shape that's as close to a square as possible that has an area of 12. So that means I have 3 squares left over that I need to somehow add to this shape to give it an area of 12. Well, I notice this. Side length 3, side length 3. I could take these remaining 3 squares that would make this shape have an area of 12, and I could cut them in half. And then I could take 3 of these halves and add them onto one of the sides. So let's take 3 of these halves and add them onto one of the sides, like so. And then I'll take the other 3 halves and add them on to the top or the bottom. I'm going to add them on to the top, like that. Now look at this. I don't have a perfect square. I have something that's close. And check this out. Check out the side lengths. From here to here is 3.5. From here to here is 3.5. From here to here is 3.5. And from here to here is 3.5. But it's not a perfect square. But I can estimate that the square root of 12, because this shape has an area of 12, right? This is 9, and these 2 parts make 3 more for 12. So a shape that has an area of 12 has an approximate square root of about 3 5/10. And I can't flip to my calculator because it'll end the video, but if you check this on the calculator, you would get, if you typed in square root of 12, you would get a square root of about 3 46/100, I think, which is about 3 5/10. So when we're estimating the square root of an imperfect square, we don't get an exact answer, we get an approximate answer. Let's take a look at another one. Okay, let's say I want to estimate the square root of 20. Well, 20 is not a perfect square. The closest perfect square to 20 that's below 20 has an area of 16. Now I want my shape to have an area of 20, which means I have 4 squares remaining that I want to add on to this shape to get an area of 20. Well, look at this. I have side length 4, and I have 4 squares remaining that I want to add on to this. So just like the last one, if I cut them in half, I would have 8 little red sections, 8 little halves that I could add on to my blue square. So let's do that. I'll add on 4 of them here on the side, and I'll add on, this time I'll maybe add the other 4 onto the bottom. Now check out what I get. I don't have a perfect square because I'm missing this little section in here, but check out each of the sides of my imperfect shape. I could theoretically say this is, from here to here is 4.5, from here to here is 4.5, from here to here is 4.5, from here to here is 4.5. So my side length is approximately 4.5. So the square root of 20 is approximately 4.5. And that's how you show that square root visually. It's an approximate answer because it's not a perfect square. Okay, let's do a couple more, but from this bottom activity, activity 3. Let's say I want to estimate the square root of 18. Well, the closest square below 18 is a 4 by 4 square. It's an area of 16. I want my shape to have an area of 18, which means I will have this time only 2 squares left over. Now I want to equally add these 2 squares to 2 sides of my square. So how can I chop these 2 squares up equally to add them to these sides here? Well, there are 1, 2, 3, 4, 8 parts and 2 squares. So if I divide them into quarters, and that's sort of tough to show on here, but I'll do it. So half, quarter, quarter, half, quarter, quarter. I now have 8 little sections that I can add on to my blue square. So I'm going to add on these quarters. So we'll add a quarter there on the bottom, and we'll add 4 of those quarters here on the side. And now my square has an area of 18. This is 16, and the red parts make 2 for 18. And if I check the approximate length of each side of this imperfect shape, because it's not a perfect square because of this part, I get that this is 4 1/4. From there to there is 4 1/4, 4 1/4, 4 1/4. So the square root of 18 is approximately 4 25/100, or 4.25. If you check that with a calculator, I think you'll get 4.24 in a bunch of decimal spots because it's not an exact answer, it's approximate. Let's do one more. Let's say I wanted to estimate the square root of 5. Well, the closest perfect square to 5 that's below 5 has an area of 4. It's a 2 by 2. Now I want it to have an area of 5, which means I have one little square left over. Now I want to chop up that one little square and add it to 2 of the sides of this square. So if I count, there's 1, 2, 3, 4, and 1 square. So just like the last one, if I chop it into 4 parts or into quarters, I can add those little quarters, those 4 quarters, onto the side and the top or the bottom. So I'll add 2 of the quarters onto here, 2 of the quarters onto here, and now I have a shape that's not a perfect square, but it has an area of 5, and the approximate square root will be the side length of each of these sides. So it's 2 1/4, 2 1/4, 2 1/4, 2 1/4. So the approximate square root of 5 is the side length of this imperfect shape, which is approximately 2 1/4, or 2 25/100. So that's how you visually show the approximate square root of imperfect squares. The assignment the kids had today was to complete the rest of this paper, drawing out what these imperfect squares would look like and what their approximate square roots would look like. I hope that helps. That's all for now. Flexing Teacher Weber, out.